All right, now we're going to go ahead and do this part B of example 8 for section 7.2. We are going to have two choices with this. You can quite literally do the monomial times this binomial and then multiply that product by the r plus 3, which would be a binomial times binomial, or you can do the binomial times binomial and then multiply it times the monomial. It's my preference to do the binomials first because I know the pattern that I'm looking for there, and it makes it a lot easier for the multiplication in my mind. So I'm going to do it that way. So I know that my first terms will multiply, giving me a 5r squared here, and then I know my outsides are going to multiply, which will give me 15r's, and my insides will multiply, which will give me one more r. So that'll give me a total of 16r's, and then finally my last will multiply, which will give me a 3, and then I can go ahead and distribute the first one through here, the negative 3r, and that's going to give me a negative 15r cubed plus a negative times a positive, which is a negative, so I can either leave that as plus a negative, or my preference actually as a negative, and 16 times 3 is 48, and r times r is r squared, and then a negative times a positive again is a negative, 3 times 3, which is 9, and those are r's, and that would be my final answer. So that would be my preference. I make more mistakes personally when I multiply the 3 through this binomial and then multiply that resulting binomial times this one, because then I'm multiplying two binomials that aren't alike, and I can't just follow patterns, and I actually do quite well with patterns, and so you'll find me following along with patterns more than I will just kind of branching out on into the unknown, because then I don't have any way of kind of subconsciously checking myself. All right, now we're going to talk about multiplying a polynomial times a polynomial. And the way that I'm going to show us to multiply these two polynomials is going to be very similar to long multiplication. So I'm going to stack these two polynomials as I would with long multiplication. And with long multiplication, you remember you multiply the ones through all of the place values, and then you put a 0 in, and then you multiply the tens through all the place values. That's exactly what I'm going to do with these. I'm going to multiply the first degree through the polynomial here, and then next line I'll multiply the second degree through. And instead of place values, I'm going to have degreed terms, kind of like when we were adding and subtracting polynomials in columns. So 3 times 5, which is 15, and the thing that I need to remember is to put pluses or minuses in here to keep track, and then 3 times 4x, which is 12x, and then that's a plus, so I'll put a plus in there, and 3 times x squared, which gives me 3x squared. Now, when I go down to my first degree term, I'm going to be moving over, right? Because a first degree times a constant is going to give me a first degree, and I need to add up those like terms, so I'll move over. So 2 times 5, which is 10, and those are x's, and that's a plus, so I'll put in a plus here. And then 2 times 4, which is 8, and x times x, which gives me x squared, and that's a plus, so I'll put in a plus there. And then 2x times x squared, so that's going to give me a 2x, and x squared times x is x cubed. And now I'm going to add these up, just like I would when I were doing long multiplication. So 15 and nothing is 15, and that gets a plus put between it. And 10 and 12 is 22, and those are x's. And then plus 8 and 3, that's 11, and those are x squareds. And then plus, and then 2x cubed. And that's the last term, and now I can box it. That's my answer. So this method of multiplying two polynomials is just a way of keeping track of the like terms so that it's easier to add them up. Because when you multiply a polynomial like this times a binomial, what you're going to get if you do the distributive property, this through all the way through here and then this all the way through, is a big string of 6 different terms, and then you have to find the ones that are alike. And it's a little bit more difficult than multiplying a binomial times a binomial, where you only have 4 terms and the only ones that are alike are just the x terms. So this calls on our knowledge of adding two polynomials in a columnar fashion, and that's why we learned that earlier. All right, why don't you go ahead and see if you can do this trinomial times trinomial, and then come back in the next video and give it a check.